Hello folks, we are coming to the part 3 of the exercise 2.1. Last video we had taken up some problems on Cartesian product. We continue with what we were doing in the previous class. Now it is our previous video. Now this is our question number 7. Now in the question number 7, they give us a set A, B, C and D and they ask us to do certain verifications. Like for example, they ask us to verify A cross B intersection C equal to A cross B intersection A cross C. They ask us to verify that A cross C is a subset of B cross D. So what we do is, whatever that we require to verify, all those in parts we will find it out and keep. Once we have found it out, then we can easily verify as to what is required. So that is what we will be doing now. We will find out all this that's been asked, we will find it out and then we will check whether it is equal or not. So let us see how to go about doing this. B intersection C, B intersection C, amongst B and C, what is common? Nothing is common. So therefore, it's an empty set. So we don't have to write all this. B intersection C, if we carefully see, there is nothing in the intersection, it's an empty set. Then A cross B. So with A and B, we have to see what the intersections are coming up like. A cross B, first element from here, second element from there. So it's like 1, 1, then it is like 1, 2, then we have 1, 3, then we have 1, 4. Then we have the next element 2, 1, then we have 2, 2, we have 2, 3, we have 2, 4. So these are the elements in A cross B. Now we can come across A cross C and see what are the elements there. We have 1, 5, we have 1, 6, we have 2, 5 and we have 2, 6. So those are the elements in A cross C. Now we come to B cross D. Let's see how many elements. There will be lots of elements because 4 and 4 in each set. So let's start with 1 there. 1, 5, 1, 6, 1, 7, 1, 8, then 2, 5, 2, 6, 2, 7, 2, 8, we have 3, 5, 3, 6, 3, 7, 3, 8. Similarly, you have 4, 5, 4, 6, 4, 7, 4, 8. So many elements are there in the Cartesian product of B cross D. We will also check what is A cross B intersection C. Now B intersection C is an empty set. So A with an empty set, we cannot form a cross product because you can take an element from A, but we don't have an element in B intersection C, we don't have an element. So we cannot form a Cartesian product. So that is why this is also going to be an empty set. That's an empty set. Now we'll go for the verification. What all they have asked us. Here, now, they ask us to show that A cross B intersection C is equal to A cross B intersection A cross C. This we already have. It's an empty set. So let's consider A cross B intersection A cross C. And let's check. Between A cross B and A cross C, is there any element that is common? Intersection means we take common elements. So is there any element that's common amongst them? Nothing. There's no common element. So automatically it becomes an empty set. Therefore, A cross B intersection C becomes equal to A cross B intersection A cross C and both are in turn empty set is verified. We verified it. That's our first subpart. Now let's consider something else. They have also asked us to verify that A cross C is a subset of B cross D. So look at A cross C and look at B cross D. It appears to be a subset because here there are only 4 elements and here there are so many elements. And let's check every element from here whether it is belonging to B cross D or not. 1, 5, yes, it's there. 1, 6, yes, it's there. 2, 5, it's there. 2, 6, it's there. So automatically when you have a set whose all the elements are there in the bigger set, it becomes a subset. So also we observe that A cross C is a subset of B cross D. And becomes clear when we do these underlining, it becomes very clear that yes, they do belong. Also we observe that A cross C is a subset of B cross D. So that is also, so this is also verified. So we have done the verification of the 7th question. Now we quickly move to the 8th question. 8th question says that if A is 1, 2 and B is 3, 4, then write, oh yes, that's a pretty big question. A is the set 1, 2 and B is the set 3, 4. You have to, not only that, you have to list what is A cross B. You have to also list all its subsets. Now, the number of subset of a given set is 2 raised to the number of elements there. If A has got 2 elements and if B has got 2 elements, A cross B will have 4 elements, the product. And the number of subset will be raised to, that means 2 raised to 4, 16 subsets will be there. Let's list it. So, first thing that they ask us to find out is A cross B. A cross B is easy, we can find it out. It is 1, 3, 1, 4, then 2, 3, 2, 4. So that's there with us. Therefore, how many elements do we have in A cross B? We always know that we have it as number of elements in A into number of elements in B, that is 2 into 2, 4. So therefore, number of subsets, I think they have asked. List how many subsets does A cross B have? Subsets. Number of subsets of A cross B. Is 2 raised to 4 and that's 16. That's how it is. If it was having 3, it would be 2 raised to 3. If it was having 5, it would be 2 raised to 5, that way. Now this is having 2 raised to 4, 16. Now let's go to list it. They have asked us to list it. So S for subset, let's list S1, S2, S3, that way. Now by default, always empty set is a subset and also the whole set is a subset. So 2 subsets are ready with us. So S1 and S2 is done. Now you have to do S3 so on till S16. Now there's one, you have to do it in a systematic way. First take all the set with 1 element. Then take all the set with 2 elements. Then take all the set with 3 elements. So that way we will finish all the subsets. So S2, S3 will take all the set, all the elements, these are all the subsets with just 1 element. So therefore it will be like 1, 3 first subset. Then second subset is like 1, 4. Then next is like 2, 3. Then it is like 2, 4. So all singletons are over. Now take doubletons, 2 elements. So we'll have S7. I think you'll have 6. Let's see. S7, let's have 1, 3, 1, 4, then 1, 3, 2, 3, then 1, 3, 2, 4. Then you can also have 1, 4, 2, 3. You will have 1, 4, 2, 4. You will have 2, 3, 2, 4. So these are all your double tens, 2, 2. How many? 1, 2, 3, 4, 5, 6. Yes, 6 double tens. Now we go to triple tens. 3 elements with, set with 3 elements. S13. 3 elements. 1, 3, 1, 4, 2, 3. Then 1, 3, 1, 4, 2, 4. Then S15. 1, 4, 2, 3, 2, 4. S16. We have started with 1, 3, 1, 4. This is over. These 3 are over. These are over. Then this is over. So you could also have 1 3 2 3 2 4. Just check. 1 3 2 3 2 4. So how many? 4 set with 3 elements and 6 set with 2 elements, 4 set with 1 element, and those are like by default sets. So like that you have got 16 subsets of the given set. That's all about this video. The remaining questions we are taking it up in our next video. Thank you.